This is the humidity video with Mrs. Lehnert. You've probably seen humidity and you never even realized it before. If you've ever seen water forming on windows like this, even though it's not raining outside, and sometimes the water forms on the inside of your windows, or if you've ever gone outside where there's grass and you've seen dew, D EW, dew on the ground, these things are actually caused by humidity. And so today that's what you're going to learn about. For the notes today, you are going to need your science notebook, your BFF, your Earth Science Reference Tables. We're going to be looking at page 12 today. A pen or a pencil, and if you have one, a calculator might be helpful. If you're listening to this without the volume, please make sure you turn it up. The first thing you want to do is set up your notes. We're going to set this up on page 53 today. I know that we are skipping at page 51 today because we're going to take some notes on Friday on page 51. So those notes are going to take place on Friday. So you're skipping page 51, and we're going to start the notes on humidity today on page 53. So you want to, on that page, make sure you write the title, make sure you record this learning objective, and once you're done with all of that, make sure you update your table of contents. You can just skip a line for page 51 and we'll enter that on Friday. Remember, if this video is going too fast for you, you can always stop, pause, and rewind so that way you can catch everything. So humidity is how much water vapor is in the air. Now remember, we've talked about water vapor before, and we know that this is a gas. So we cannot see this water vapor that's in the air. By the way, make sure that you are recording this definition in your input page right now. And sometimes we also call humidity, sometimes you'll hear us call it relative humidity, which is measured in a percentage. And just like you would measure your grade in a class, in terms of percent, the highest is 100% and the lowest would be 0%. So again, make sure you're capturing this in your input page. And I'm just going to kind of talk through what that means. So for example, if you are outside and you tell your neighbor or your friend, hey, wow, it really feels humid outside, what that means is that there is a lot of water vapor molecules in the air. So for example, on this day where it's 95% humidity, it's going to feel really humid. Sticky is another word that sometimes people use. And if there's not a lot of water vapor in the air, meaning there's not a lot of water vapor molecules like here on the right-hand side of the diagram, then we would say that's low humidity. This is only 10% relative humidity. So there's not as much water vapor in the air. Humidity tends to make us feel sticky, or it really messes around with your hair. Some people, their hair goes flat, and some people, their hair goes frizzy. So humidity plays a big role in how we feel when we go outside. So let me tell you a little story. This whole idea of us feeling something because of the humidity is really because when it is humid outside, we sweat more. And this is because of two things. First of all, when our sweat evaporates, remember that's when it turns from a liquid, the liquid that's on our skin, and that's when it turns into a gas. So when it evaporates, it's actually turning into water vapor. That process of evaporation is something that cools us down. And you know this because if you stand in front of the fan when you're really sweaty, it's like, oh, it just feels so much better because that sweat is actually evaporating and it's cooling you off. You have these little sweat glands underneath your skin and they release liquid water. That's all that is. Your sweat is just liquid water. Of course, it's mixed with, salt and some other things. But that liquid water on your skin, when it evaporates, cools you down. So why is it when it's humid outside, we sweat more? This is because if the air is already 100% humidity, meaning if it's really, really humid out already, it is full of water vapor. So our sweat is not going to really evaporate because it has nowhere to go. If your sweat is going to evaporate, it means that you're adding more water vapor to the atmosphere, to the air. And if it's already full of water vapor, it just can't take anymore. It's kind of like if you had a full glass of water. If you tried to add more water to this glass, it would overflow. You can't put any more in it, right? But if and this is kind of like 100% humidity, relative humidity. But if your relative humidity is only 25%, you can add a lot more water to this glass, just like you could add a lot more water vapor to the air if it's only 25% humidity. And so when it's really humid outside, we tend to sweat more. And because when we sweat, it tends to cool us down only if it evaporates, then when we go outside and it's really humid, it actually feels really hot to us as well, even though humidity and temperature are two totally different things. The bottom line here is that nobody ever says that they love humidity. It's really rare that anybody says, "Oh, I love it when it's humid outside," because usually it just makes you feel sticky and gross all the time. Okay, so we measure humidity with an instrument that is called a psychrometer. This P is actually silent. So we don't actually pronounce the P. We pronounce this psychrometer, kind of like psych. And it actually comes from that word. This psychrometer part actually means cold or to cool off something. And if you are watching this after we did our lab up on the roof, that kind of makes sense because you used a psychrometer up on the roof, and one of the thermometers had a wet cloth. Sometimes they'll call it a sock around it. And when that wet cloth was around that thermometer, it cooled it down. And so that thermometer was always going to be a lot cooler than the dry bulb thermometer. And so that's where this word psychrometer comes from, because it has one of those wet bulb thermometers on it. Okay, here is your first check for understanding. And here is a second question. Okay, hopefully you got those right. Um, Another thing that is related to humidity is something called the dew point temperature. You might have heard weather people talk about this dew point temperature. It sounds really complicated, but actually it's really simple. The dew point temperature is kind of an imaginary temperature at which water vapor in the air condenses. So again, make sure you're capturing this in your input page. So you should remember what that word condense means. It's just like the word condensation. And we learned that when we did our water cycle unit, and that's when you have the gas turning into a liquid. We saw this in the water cycle when we were talking about clouds, because when water vapor in the air turns into a liquid, that's how we get a cloud. But in this case, sometimes you get a cloud when you reach the dew point temperature, and sometimes you get things like dew or frost. And so the dew point temperature is literally a temperature. It's an imaginary temperature that exists. And then if the actual temperature in the air reaches the dew point temperature, that's when you get a cloud, or that's when you get dew or frost. So that might be a little bit confusing. So let me clarify it a little bit. So generally what happens is when the dew point temperature equals the air temperature, the humidity is 100%. So when those two temperatures are actually the same, you're going to have a very, very humid day outside. So for example, let's say the dew point temperature is 45 degrees Fahrenheit. And let's say the air temperature is also 45 degrees Fahrenheit. Then that means the humidity outside is going to be 100% and it's going to feel really sticky. So one of the things that I always look at when I'm getting ready for the day is I look to see what the dew point temperature is. Because if the dew point is really close to the air temperature, I know it's going to be sticky outside. And I just want to make sure that I'm prepared for that. So how do I prepare for that? Well, if the humidity is 100%, like I said, it's going to feel sticky outside. And a lot of times, if the humidity is 100%, it's probably raining or snowing. Or if it's not raining or snowing outside, there's probably dew on the ground. Now, for you and I in the city, that might not mean anything because we might not have grass where dew can collect on the grass. But if you live out in the country or farther away from the city and you do have to go out in the grass, for example, my dad always goes out in outside to get the paper, and inevitably the paper is usually somewhere out in the lawn because the paper boy has missed the front door and he has to go out in the lawn and get it. On days where the humidity is 100% in the morning, he gets so mad because there's dew on the ground and he goes out in his socks. And so then his socks get all wet because the water vapor in the air has now condensed on the grass. And that's where that water comes from. You've probably seen this on containers, right? If you have a container of water, like really, really cold soda, and you take it outside, little droplets of water form on the outside of it. That is condensation. And that's because the temperature of the air that's right next to the can has reached the dew point temperature. And the condensation, the water vapor is all turning into condensation on your can or your water bottle. It's not that your water bottle is leaking, it's that that is coming from the actual air. And then what I think is kind of cool is if the temperature is actually colder than the freezing point, then all of that water is going to freeze. And that's how we get frost on our windshields. You might see that sometimes in the morning on a really, really cold morning. Some of the cars along the street have frost on the windows. That's just frozen dew. That's all that is. And all that means is that the humidity is probably 100%. Okay, last couple of things that you should know. The dew point temperature is always, always colder than the air temperature. Well, unless it's the same. Sometimes it's exactly the same. But the dew point temperature will never be warmer. So that means if it's colder, it's always going to be a lower number than the air temperature. Another thing that sometimes trips up some students is they think that the dew point temperature is the same as the wet bulb temperature. Remember when we measured in our lab on Wednesday the wet bulb temperature, this wet bulb thermometer right here? It's not the same. So this is not the dew point temperature. So they're different. And then finally, just like we measure relative humidity with a psychrometer, we also measure dew point with a psychrometer. So the same instrument measures relative humidity and dew point temperature. Okay, time to check your understanding. And here is another one. So once you get the dry bulb and the wet bulb temperatures from your psychrometer, and this is what we did in lab on Wednesday. Once you use that psychrometer and you figure out your dry bulb temp and you figure out your wet bulb temperature, there are other steps that you need to follow in order to get the humidity and the dew point temperature. So we're going to do those right now. So our first step is already listed there on your input page. And on these thermometers, each of these are going, let's see, there's 1, 2, 3, 4, 5 lines. So each of these are going up by 2. So because these are going up by 2s, this is 20. So that means this must be 22 because that's 30. So the dry bulb temperature in this case is 22 degrees. And on yours, it says up here, even though it's hidden up here, it says that it's degrees Celsius. So on your paper, I want you to make sure that you record dB, which stands for dry bulb, equals 22 degrees Celsius. You can do that right next to the dry bulb thermometer on your input page. And you should be able to figure out what the wet bulb temperature is. Go ahead and do that right now and record wet bulb equals however many degrees Celsius you think that is. You could even pause the video right here before I give you the answer to see if you get it right. Okay, what you should have gotten is 12 degrees Celsius because this is 10. These are going up by 2s, so this would be 12. This would be 14, 16, 18, and 20. All right, so our second step, you want to subtract them to find the difference. Make sure you record this on your input page. You might pause the video while you're writing this before I go on to the next step. So if we were to subtract our dry bulb minus our wet bulb, we get 22 degrees Celsius minus 12 degrees Celsius. And you should do this again at the bottom of your input page there. 2 minus 2 is 0, 2 minus 1 is 1. So I get 10 degrees Celsius. This is my difference. Step 3, find your dry bulb temperature on your BFF, your Earth Science Reference Tables, on page 12. So this is at the top of page 12 that we're looking at because it has the dew point temperature. So we're going to find the dew point temperature first, and then you can see at the bottom of page 12, you have exactly the same chart. It just says relative humidity at the top of it instead of dew point temperature. So if you remember, our dry bulb temperature was 22, and I know that this column here on the far left, it says that it's the dry bulb temperature. So all of these numbers are dry bulb temperatures. Another word for dry bulb temperature, by the way, and you should write this in your BFF, same thing as your air temperature. So air temperature or dry bulb temperature, it is all exactly the same thing. Okay, so it's just the temperature outside. But we call it the dry bulb temperature because it's the one without the wet little piece of cloth on it. So 22 degrees was our dry bulb temperature. Great, that's step 3. Step 4, you need to find the difference at the top. And notice I capitalized difference. Make sure you record that in your input page. That's step number 4. Because at the top of this chart, it literally says difference between wet bulb and dry bulb temperatures. So you're going to take the difference that we calculated by subtracting. I want you to write this at the top of your BFF, subtract. So we're going to take our dry bulb temperature that we found was 22, and our difference, the number that we subtracted to get, was 10, remember. Remember, our wet bulb temperature was 12. Notice we are not looking up 12. This is probably the most common error that students make on the Regents exam. They'll look up the wet bulb temperature, but you need to look up the difference, okay? So you find 10, which is our difference, at the top. Step 5, follow the numbers until they meet. So we found the dry bulb was 22, the difference was 10. If we follow 22 over and we follow 10 down, they meet right here, and that is our dew point temperature. And the last step, step number 6, is don't forget the units. So when we find out that the dew point temperature is 3, you need to include the units. The nice thing is they tell you, dew point right up here, they tell you that the units are degrees Celsius. So degrees Celsius for our units. Now, if you were asked to figure out the relative humidity instead of the dew point temperature, you would follow the exact same steps. The only difference is that when you figure out 22, 10, follow them down, follow this over, this time you get 27, and instead of 27 degrees Celsius, the units would be percent. And so it's 27% relative humidity, and that's it. All right, let's see how well you understood those last steps. You're going to check your understanding by answering this question. What is the dew point temperature if the dry bulb is 16 degrees Celsius and the wet bulb is 10 degrees Celsius? Follow your steps to figure out your answer. All right, so hopefully you got that right. If you said negative 10 degrees Celsius, that was not right. You probably used the wet bulb temperature instead of the difference to figure it out. And if you said either 45 or 14, you probably used the wrong chart. You probably used the one at the bottom, which was for relative humidity, instead of the one at the top, which was for dew point temperature. So hopefully, if you didn't get those right, let's give it another chance. We'll give you another question. So this one is asking about relative humidity. What is the relative humidity if the dry bulb is 24 degrees Celsius and the wet bulb is 14 degrees Celsius? All right, hopefully you did better that time. Again, if you used just the wet bulb temperature instead of the difference, you probably got the wrong answer of 9%. The correct answer should have been 30%. You just got to remember to subtract and not use the wet bulb temperature when you're using that chart. And if you got the answer of either 6 or -10, then you probably used the wrong chart again. You probably used the dew point temperature chart instead of the relative humidity chart. We'll do more practice with this on Monday. So if you didn't quite get them, that's okay. We'll do more practice on Monday. Hopefully you'll get better at it.